Assalamualaikum warahmatullahi wabarakatuh. Thanks you for coming to this presentation. I'm glad to see you all. Let me first introduce ourselves. My name is Rita Pramujiyanti Khotimah. I'm from UPSI and UMS, and my partner are Associate Professor Dr. Maslini Atan, Associate Professor Dr. Chen Isam from UPSI, and Professor Dr. Budi Murtiasa from UMS. In this opportunity, I would like to present the development of STEM-based discovery learning module in differential equation or one-to-one evaluation. This is outline of my presentation. The first is introduction, second research methodology, third result and discussion, and fourth is conclusion. Introduction. Differential equation is a branch of mathematics closely related to daily life problems. The learning of differential equation tends to be textbook-oriented. Not many use the modules. Khotimah et al. 2020. Several learning modules based on STEM or based on discovery learning model have been developed. However, there are no studies about the development of the STEM discovery learning module in the topic of differential equation. Based on the need analysis in the preliminary research, the STEM Discovery Learning Module development is in high demand for teaching and learning of differential equation. Plum 2013 states that one of the most important stages in the development phase is the formative evaluation, an evaluation that aims to improve and perfect the prototype developed. Dasa Prawira, Zulkardi, and Susanti state that one-to-one evaluation used to find out the shortcomings of the prototype based on student opinions. Tesmer 19 and 93, as cited by Plum 2013, state that the purpose of the one-to-one evaluation is to identify the clarity, appeal, and obvious errors of the prototype. The research question in here is how the formative evaluation result of the STEM discovery learning module by using one-to-one evaluation. Methodology. Research design. The research employs design research. Design research implies the systematic study of designing, developing, and evaluating educational intervention such as programs, learning process, learning environment, teaching learning material, products, and system. Tesmer, as cited by Plum 2013, revealed that the prototype would be tried out and revised based on formative evaluation consisting of expert review, one-to-one evaluation, small group, and field test evaluation. This article only focuses on one-to-one evaluation. For the other formative evaluation states will be further discussed in a different article. Research subject. The research subject were the 3 college students of Mathematics Education Program FKIP UMS. The data collection techniques are interview and documentation. The data validation use source triangulation, and the data analysis use the flow method, which consists of data redaction, data display, and conclusion. Research result. One-to-one evaluation is carried out in parallel after the expert's evaluation stage. In the one-to-one evaluation activity, the researcher gave the module to 3 research subjects. After the subject were allowed to read the entire contents of the module, then interviews were conducted. The figure 1, this figure describes the interview process via Google Meet. The interview in the one-to-one evaluation was conducted to obtain student responses regarding clarity, performance, and obvious errors in the module. The following are the description of the module evaluation result by students at the one-to-one evaluation stage. The first is module clarity. The clarity of the module in the study is seen from the clarity of the activity steps in the module, language, mathematical symbols, and the time allocation given in the module. And this is the interview result with the 3 subjects. Module clarity. For the activity steps, the subject state that activity steps in the module can be clearly followed. However, the subject still had a little difficulty in completing the activities in Discovery 1, namely at the data collecting stage. For language and symbol, the language in module is clear, very communicative, and easily understood. The mathematical symbols were precise and clear. The writing of symbol is easy to understand and easy to read. And for the time adequacy, the students state that time allocation for its discovery in module was sufficient for students. The result of interviews become the researcher evaluation material to make the improvements. This is an example of improvements that have been made by researchers based on the student comment in Discovery 1. And this is the data collection before and after revision. The second result about module performance. Based on the interview, the student state that the module is attractive, both in terms of design, color, and appearance of the letter. The design is interesting, the colors are not monotone, and the font size is right. It is not too small and too big, and it is easy to read. In the module presentation, the students state that the content module presentation is coherent, making easier to read, and the concept placement are quite clear from the beginning. The third results about obvious error. The obvious errors in this research are errors in the module with legible or visible. Based on the result of interview with the subject, several errors were found that were visible in the module as follows. In Discovery 2, page 21, Discovery 3, pages 71 and 78, some of the links provided in the module are not clearly visible because the color of the text on the link is the same as the background color of the text. And then second, Discovery 2, pages 48, 55 to 60, and pages 78, 68, 72 to 74. The students state that some symbol writings are not clear and have a question mark. In Discovery 2, pages 62 to 63, and Discovery 3, pages 83, some of the mathematical symbol size are inconsistent. And in Discovery 3, pages 66 and 77, some of the sentences are underlined. These are the example of revision of the module about the writing symbol. This is before and after revision, some example, and this result is in line with the research conducted by Ahyan, Zulkardi, and Dharma Wijaya in 2014, revealed that in the one-to-one evaluation stage, the subject still had difficulties in solving math problems in the PISA model of change and relationship content developed. Based on suggestion from students at this one-to-one evaluation stage, the improvement of prototype were made. Nisa et al. Also carried out a one-to-one evaluation stage on student book-based STEM about distant material in three-dimensional space. This activity is carried out in conjunction with the validation process by experts. And based on the result of interview with 3 students, it can be seen that the difficulties experienced by students in working on the student book. The result of this one-to-one evaluation were then used to improve the first prototype student book that had been developed. The result of the one-to-one evaluation is research on the development of discovery learning-based module with a scientific approach, so that there were some sentences in the module that were still not clear and asked by students, so that further product revision were needed. This is a research that conducted by Elisher et al. In 2018. Saspanda and Sarifuddin in 2018 also made improvements to the concept attainment model or CAM-based mathematics learning device based on the result of a one-to-one evaluation of 3 grade 8 students with different ability level. Conclusion: the formative evaluation through one-to-one evaluation in this study can be used to identify clarity, attractiveness, and obvious errors of STEM discovery learning module. The result of one-to-one evaluation used to improve and to perfect the STEM discovery learning module so that it will be ready to be evaluated in the next formative evaluation stage. That's all my presentation. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.